Hello! BLE tags are extensively used today for Internet of Things applications that require detection of location. Yodivo platform offers an awesome environment for developing such applications. In the video you are watching, we will use a BLE tag made by Dialog Semiconductors and configured to transmit iBeacons, which are then received by an iOS phone running the Sensor Hub application of Yodivo. The application forwards the iBeacons to Yodivo cloud server, and then nice services can be made, as you will see. You can register to Yodivo Cloud Platform if you go to cyan.yodivo.com and sign up with either your Google or Facebook or LinkedIn account. I will use my Google account this time to sign in, and in the first page I can see the nodes that are already paired with my account, and those come from three smartphones that run the Yodivo application, which is called the Sensor Hub, that is provided for either Android or iOS smartphones. I can now use the Cyan editor, which is a nice user interface that allows me to interconnect things from the paired nodes through ready-made logic provided by Yodivo. I will create an application which is a smart lighting system that is based on the relative position of the iPhone to the BLE tag. And in order to make this, I will use the think of the iPhone node, which is called iBeacon, that gives me useful information about the proximity level, as well as the RSSI and the contents of the beacon that is transmitted from the BLE tag. And what I need to do next is to detect the various proximity levels that my application will be based on. I will use three different values in this application, so I need three text matchers or text comparators. I can either drag and drop those blocks from the list of things here in the left, or simply copy the blocks by using this nice feature and cloning them like this. Now I can connect the proximity level output with the three inputs of those comparators, and then configure those comparators to detect the values I want. The first one will be used to detect the far proximity level. The second one will be used for the near case. And the third one, very similar to the second one, but for another value of the proximity level, which is the immediate one. Finally, I will need a fourth text matcher to detect to compare the ID of the received iBeacon with a predefined value, which is the ID that I have used for the BLE tag, and for case of simplicity I have used an all zeros value. Now that I have finished with the text comparators, I need some logic to make sure that I detect the case that the iPhone is close to the BLE tag by combining the near and immediate proximity level values, and then gate the output of the OR logic with the output of the ID comparator. And finally, the last thing I need is a light to drive, it is very simple for me to use the backlight of the iPhone. So when the iPhone comes close to the BLE tag, the flashlight will switch on. Similarly, I will use an AND gate to detect when the proximity level value is far, and of course when this comes from this specific BLE tag, in order to drive another light, and let's use the flashlight of the Android phone. So I have almost finished with my graph. The last thing that remains is to connect the output of the gate with the input of the flashlight, and I'm ready to save the graph. I need to select a name for this graph. Let's say iBeaconTest. Okay, the graph was saved successfully, and the last step is to deploy the graph. Deploy successful, and I'm ready to see how this works in real life. The BLE tag is at a certain place in the corridor, and far from that are the two smartphones with the backlights that are controlled by the graph we just deployed. You see the Android phone on the chair, and Maria holds the iPhone, which is too far from the tag, so the iBeacons it receives have low RSSI, and the proximity level it sends to the cloud server is far. And that keeps the backlight of the Android phone switched on, while the backlight of the iPhone is switched off. She will now start walking towards the tag, and when she is close enough, the proximity level will take the value near. That will turn on the backlight of the iPhone, and at the same time it will switch off the one of the Android phone. Now Maria will go back again, and the two backlights will toggle since the proximity level will indicate far again. While watching this video, you might already think of target applications that need automatic control of lights or other network devices based on the relative position of a beacon receiver with regards to the transmitter. With your Devo Cloud platform, such applications can be made in a few minutes. We'd be glad to help you providing groundbreaking solutions to your customers, so please contact us to figure out how we can bring your BLE product offering to a superior level. Thank you very much for your attention.